Alright, today we are going to solve LeetCode 128, which is called longest consecutive sequence. So the question asks, given an unsorted array of integers, find the length of the longest consecutive elements sequence. Your algorithm should run in linear time. Okay. So in this example, we have 1, 2, 3, and 4, which makes a chain of 4 elements. So longest consecutive elements of sequence, I will call it a chain, and the answer is obviously 4. So how can we do this in like linear time? So the idea could be like hash all the elements and apply DFS for each one until you reach a visited element. Okay. The idea will run in ON time. Why? Because as we are going to make markings on every element that we visit, we will not visit that same element ever again. So we cannot visit an element like twice or more, which makes it ON time. So the DFS will run in ON time, but every element will be only visited just once. So let's see some example. Let's use this example and see what we are going to do. And I will keep two unordered maps. Let's call them UMP1, UMP, which says basically an element exists. So 100 will keep the value true, 4 is going to be true, 2 is true, etc, etc. You get the idea. So I will use this thing to search for elements. Like if I am on this one, I will look for 0 and 2 because those are two consecutive elements to 1, and I will see that 2 is a element that has a value of true in this unordered map, so I can go there if this is not already visited. So I will keep another thing which is called visited. Let's initialize everything with false. Okay, and then what we are going to do is, let's start from here. I will make it immediately true, and I will try to go 101 or 99, and obviously they are not here. So what we are going to do is we are just going to come right here. We are just going to look for this one. So we will make this visited, and we will see if there is a 3 and there is a 5. There's not a 5, but there's a 3 here. So what we are going to do is we are just going to come here and make it a true, which is already visited. So if we are on 3, we are, by the way, we are counting the length of this chain when we start from a position. So we have something like this one, and this is true, and this has some consecutive elements in the array. So let's go to right hand side first. So 2, and we will make it true. And 2 can have 3 or 1 as consecutive elements. It cannot go back to 3 because it is already visited, but it can go back to 1. So we will go there and make it true, and we will have this beautiful chain of 4 elements, right? So this is going to be used to update the answer we are keeping. And then we will just come back here and we will see that this is false, right? We will make it true, and we will see that it cannot go anywhere, and we will iterate through this thing. So we start from here, we came here, we immediately came to 3, 2, and we came to 1. And then what we did is we came to 200. We saw that it cannot go anywhere. We made it true. We came to this one. It is already true. It's already true. It's already true. So we are done. So what we did is we just traversed through the array just once using the help of these two unordered maps, and we finished our process and we updated our candidate answer, and the answer is returned to be 4. So let's try to code it, and we will understand it better, I think. So let's let's just initialize an n here. I do not want to work with the size function of C++. So let's see. At first, I will see that if nums is empty or not. If it is empty, I will return 0. I do not want to work with that. And then I will make that n is num size. And let me initialize this unordered maps. The first one will be integer boolean, which is going to be called, let's say, UMP. This will keep elements. Okay, and then I will have another unordered map, which I will call visited, and mark elements visited. Okay, and do I need anything else? Yeah, I just need a vector of integers, right? Let's call that array, and this array is going to be nums itself. Okay, so I will make it a global array, and then let's just initialize this unordered map, and yeah, and everything else here is going to be false, right? We do not have any integer in this visited array. So let me start like this: I is smaller than n, I plus plus. Okay, what I'm going to do is ump nums I or array I, it doesn't matter right now at the moment, is going to be true, and of course visited this thing is going to be false, because these are not visited yet. Okay, sorry. So what are we going to do next? We are just going to initialize an answer here. Let's initialize that with 0, and what we are going to do is we are just going to iterate through the array, okay, in this for loop, and we are just going to check if that thing that is nums I is false, right? Because if this is visited, I do not want to see that answer. And I will update the answer right here. I will take the maximum of answer itself and a function I will create, which is going to be called DFS, because as you can see, we just go to the places where we have consecutive elements, so which is possible with DFS. So what we are going to send here is nums I right here, right? Because this is not visited, so we can start from this position to run a DFS. And at the end, what I'm going to do is I'm going to return answer. Okay, so this should return an integer as well. So let's create that function. So let's call this DFS, and let's say that it starts with a number num. So at first, what I will do is, let me see. Yeah, this is not visited, right? So okay, I do not need to check the base case here. What I can do, on the other hand, is to check if these numbers, one number that is smaller than this and one number that is one bigger than this, are existing or not. So let's see if ump num plus 1 exists and they are not visited. Okay, so okay, I put it in the wrong place. So the element that is one bigger than this number exists in the unordered map and it is not visited. So what I'm going to do is I'm going to let's create a result here, and result is going to be equal to DFS to num plus 1, because I want that side to, return the number of elements that are consecutive on this side. And we need to make sure that this DFS does not come back. So what we are going to do is we are just going to make this thing visit num true. So this place will never be visited ever again. Okay. So it's cool. So what we're going to do next is to check if ump, okay, num-1 exists. If that exists and not visited yet, because we could be coming from that place, so let's check that. It's not visited yet, so we just jumped into this place. Like let's say we start from this position. We have 3 plus 1, also 3 minus 1 in the array, so we can go both ways, right? So these are the two cases. So what we are going to do is we are just going to increase the answer here, because this will count the elements that form a consecutive sequence on our right hand side, which are greater than us, and this side will return the number of elements that form a consecutive chain that are smaller than us. So what we are going to send is num minus 1. At the end, what we are going to return is 1 plus result. Why? Because this number is also an element of this chain. And if this element does not have a consecutive element in the array, it should return 1. So that's why this will work. Okay, so let's see if we miss anything. I don't think so. So let's check. So we made a mistake. Okay, it says I59, right? Okay, so let's just delete that part and run this code. It works in this example, so let me make it smaller, like this one, because smaller cases generally, yeah, we do not have premium. Okay, it works. Let me run. Okay, so I hope you get the idea. So let's go over this algorithm once again and see if this time complexity is O(n). So here we make n operations. So these insertions take O(1) time to unordered maps. So this part takes O(n) time. And here this part is important. But this is also O(n). Why? Because when we make this call to this depth first search, we only do that search if the element is not already visited. And if every element is visited just once, this will be run n times. So if this is run just 1 times, that means the elements form a consecutive map, a consecutive chain from start to end. So it would also take O(n) time, because the FS would take O(n) time. So this thing will take O(n) time. That's why this is linear time. So thank you very much for watching.